All right, today we are diving into something really cool called NS3. You can think of it as a secret laboratory where the internet's biggest, boldest new ideas get built and tested. I mean, have you ever really thought about that? Rolling out new network technology is a super high stakes game. You absolutely have to get it right before it goes live for millions of people. You just can't. Imagine the chaos. The internet is way too complex, way too fragile to be used as a real-time test lab. So this creates a huge problem for researchers and developers. How in the world do you safely test these groundbreaking ideas? And this is where NS3 comes in. It's the answer. It's a powerful, open source simulator that gives you a safe, totally controllable sandbox to build, test, and yeah, even break the networks of tomorrow. So let's step inside this virtual lab. This is a world where we can build pretty much any network we can dream up and run perfectly clean, repeatable, scientific experiments on it. Okay, so what is it technically? Well, at its core, NS3 is a discrete event network simulator. Now that sounds a little complicated, but the idea behind it is actually really elegant. It all comes down to how the simulator thinks about time. Let's take a look at the engine that makes all this possible. See, it doesn't use a continuous clock like we do in the real world. It uses something much, much more clever and efficient. Instead of simulating every single nanosecond, which would be unbelievably slow, the simulator only cares about the specific moments when something actually happens. We call these events. So time literally jumps from one important event to the very next one. And this visual here, it shows you exactly how that jump works. An event happens, say a packet arrives at a node, that triggers a function called an event handler. That function does its job, and then, and this is the really key part, it can tell the simulator to schedule a new event for some time in the future. So you can basically think of NS3's main simulator as a super organized manager with a perfectly ordered to-do list of future events. It just grabs the next thing on the list, executes it, and if that action creates new future events, it just slots them into the list in the right time-stamped order. Simple as that. And NS3 is just incredibly flexible. You can actually swap out the simulation engine depending on what you need to do. There's a standard one for fast, simple stuff, there's a distributed one for running massive simulations across a whole cluster of machines, and there's even a real-time engine that can sync the simulation clock with a real-world clock, so you can interact with live hardware. Okay, so we've got the whole time thing figured out, but how do you actually build all the pieces, the nodes, the channels, the applications that make up your virtual network in the first place? Well, the answer is a system that feels a whole lot like you're playing with digital Legos. It's designed from the ground up for total flexibility and for reusing parts. This is all built on something called the NS3 object model. Just think of it like a master blueprint that gives all your different components a common foundation. It handles all the tricky stuff like memory management for you, and it gives you these two incredibly powerful systems. We're going to focus on one of them right now, the attribute system. And wow, this shows you its power perfectly. What you're looking at is the attribute system basically creating a map of every single configurable parameter in your entire simulation. This means you can write a tiny script that reaches deep inside a really complex object, like the physical layer of a network card, and change its transmission power, all without ever having to recompile a single line of C++ code. It's amazing. So look, a simulation is completely useless if you can't get any data out of it. It's not just about watching things run, it's about turning this model into a real scientific instrument that gives you clear, meaningful results. NS3 has a really elegant way of doing this called the data collection framework. You can think of it as a simple three-step pipeline. First, a probe latches onto whatever data you care about. Second, a collector can process that raw data on the fly, doing things like calculating averages. And finally, an aggregator formats it all nicely for whatever output you want. It's this structured approach that takes what would otherwise be a chaotic flood of simulation events and turns it into something you can actually analyze and understand. And here is the payoff. Using special helper classes, you can automate this entire pipeline. You can go from a raw data source, like keeping track of packets being sent from a node, directly to an insightful graph like this one, all with just a few lines of script. It's fantastic. So let's pull all these different pieces together for a second. Why go through all this trouble? Why build these complex virtual networks inside a simulator? What's the real-world point of it all? The benefits are just immense. First, it's about safety. You can test the most radical, network-breaking ideas without any real-world risk. It's about scale. You can simulate a network with thousands of nodes, way more than you could ever afford to build in a physical lab. It's about control. You can change just one single variable and see exactly what effect it has. And maybe most importantly for good science, it's about repeatability. You can run the exact same scenario 1,000 times to get rock-solid, statistically valid results. You know, the official NS3 manual actually puts it perfectly. It talks about older, less flexible systems and says if you want to add an IPsec security protocol between TCP and IP, you may be forced to hack the system. This is clearly not an optimal way to design a generic simulator. And that just highlights why that digital Lego approach is so absolutely critical.
And ultimately, that's what this is all about. NS3 isn't just a program, it's a complete toolkit for innovation. It gives you the modularity, the power, and the control you need to design, validate, and perfect the next generation of network protocols that are going to power all of our futures.
So it really leaves you with a fascinating question, doesn't it? If you had a tool this powerful, a safe world where you could rebuild any part of the internet from scratch, what's the first thing you'd try to reinvent? What big problem would you want to solve?